Okay, so here we are. We are actually introducing 3 products into the product range: the V5000, the 3000, and V1000. We chose to deliver 3 products because we saw multiple ways of deploying this, and one product doesn't fit all. Even two products don't fit all the scenarios we wanted. So we combined this product range to be able to give customers the best cost of ownership and the best flexibility to deliver a wireless fiber solution into their network. The V5000 is the distribution node. The distribution node is really the hub of how Telegraph works. It basically is the router, which layer 3 router, which is able to pass packets around. Every product, in fact, actually has the routing technology within inside it to look and search for different paths and to self-heal. But the DN is the hub. The client nodes are what hang off this and can be utilized for either residential purposes. The V1000 is basically fits into the palm of your hand. It's a very small device, but actually hugely powerful. It will deliver 1 gigabit per second. So it's got a 1 gig port on there. So you will get bidirectional around about 1.8 gig layer 2 data to the customer. The V3000 is it can be used for long distance, but it also is to cater for the user who demands more throughput, more data. This is capable of 3.6 gigabits per second, but it is also capable of using channel bonding, as Niraj mentioned, to go to 7.2 gigabits per second. All these devices can be using point-to-point mode. We would expect the V1000 to be residential point-to-point short hops, gigabit, and then the V3000 would be for long distance. You can get ranges over 1 kilometer. On channel 4, you could even hit way beyond 3 kilometers if you so wish to do so. At one point, well, I've got another talk later on, and we'll go into more detail on that. I briefly wanted to go through what these characters, what these products are that we're actually providing. So as you see here, the distribution node is actually 2 sectors. What does that mean? Basically, it means that we can see 280 degrees around us. So we chose this 280 degrees as a way of, as a balance between the amount of power it needs to take, the cost of the product, and also flexibility of the product. So in a very small package, as you can see, it's around about 28 centimeters tall, and actually quite thin as well. It's only around about 10 centimeters in thickness. So it actually blends very well on the lamppost or into the building. So it can be well hidden. The throughput of this, each sector is capable of supporting that 7.6 gigabits per second. But it's also basically, when you combine this, that actual radio itself can almost get 15 gigabits per second passing through this when we channel bond. So hugely capable of delivering that mesh backhaul in any circumstance, whether it's city, whether it's residential circumstances or business. The ports on it, as you see, we have a 10 gig SFP port on there, support 10 gig or 1 gig SFPs. GPON as well will be supported on that. So if you have a GPON network, then it has two other ports. You've got a 10 gigabit PoE port. So you can actually plug it straight in and get 10 gigabits through copper on that port there. It also has an auxiliary port on there, which is a 1 gigabit, a 1 gig port, and it is also a power out. So you can actually put onto that 802.3 AF or AT devices, and it will power up those and bridge the information through the radio. We have these in Wi-Fi with Wi-Fi 6, as well as standard Wi-Fi bridging modes. And we also have cameras as well attached to these in demos. I'll move on. The V3000, this is quite unique. It's this shape for a reason. It's not a dish, because dishes, you lose a huge amount of power with a dish, because you can't illuminate all the elements within a phased array. And this is what Cambium does. We can take beamforming technology. You've seen Medusa, what we can do, and we take this and we can adapt it to different circumstances. This radio is still capable, even if though it's a dish, of beamforming, and that's not something you'll see with a parabolic. So this is very unique. So that actually helps the installer with a little bit of leeway. It's plus or minus 2 degrees, but actually that plus or minus 2 degrees is huge when you're trying to size it up, aim it, and get the best signal. And also in case there's any movement as well on when you put it on. Right. So again, it has the same ports as the V5000, so very flexible, both in point-to-point and as a client node. You can power other devices off this and provide that high throughput to your customers. The V1000 is the residential side. It's a very neat solution. It's size of the palm of your hand, very small, but very powerful. This easy to install and easy to power as well for the PoE port. Simple management. The beauty of all this is to make sure you can install it simply and manage it simply. So we're building off, we can run it using the Telegraph, using Facebook's NMS, but we've integrated this into cnMaestro. If you've used the Cambium solutions before, you know about cnMaestro. Well, this now can use that single pane of glass. You're able to control your cnWave products, as well as your CN pilots, your EPMP, your PTP, your PMP products, all in one platform. Using Maestro, you can control the end-to-end controllers. These are a centralized management system where you would configure your network. You configure how you want your what configuration you want your nodes to come up in, whether it's security, whether it's power modes. And basically this centralized management system enables you to come along, put a node up there. That node will link up and be able to get its config downloaded. So makes life in installation really simple. And don't forget that beamforming technology. Didn't mention it that much actually. On the V5000, once you've got that azimuth of 280 degrees, you've also got an elevation of plus or minus 20 degrees. The V1000, you've got a 90-degree span where it can find that DN, it can then sync up and then get its config downloaded to it, and then your network is up and running. So very easy to install. None of this aiming and lining up necessary. Those beamforming, those beams will link up together. We also have an option to standalone control the unit if you want. So you can log on, and the end-to-end controller is actually built in within the DN itself. This is ideal for point-to-point opportunities or something like micropops or small networks. So as Niraj has already said on this, lots of different ways you can, as service providers, implement your network using a Telegraph system, whether it be urban, whether it be being able to get from a fiber to a point on a building and then distribute from that either Wi-Fi services indoors or outdoors. You've also got residential implications where, again, you could use rooftop or street furniture to distribute that around. And then we have industrial uses. Get onto an industrial park. I've got an example in the next presentation where you can get onto an industrial park and spread that that data very quickly and without digging up any roads. So with that, I'll come back to Niraj and any questions that you might have.
Okay, thank you very much, both of you. Thank you, Niraj, for your earlier contribution as well. I do have one question, which is geared to Anthony, really. Anthony, simple question. Why would I buy Cambium Telegraph products over the other Facebook partners?
Perhaps I should get Niraj to answer that.
I think that could be tricky.
Yeah, and that wouldn't be fair. So why ours? I think it really does come down to the total cost of ownership. The way that we've developed our products means that the range of applications you can use it in is very flexible, but also that single pane of glass as well, of you being able to manage all your products through that one single management interface, all integrated into CN Maestro. We also have, if you weren't here at the earlier presentations, it's built into Link Planner, so you can do your planning on this. Link Planner is used by millions of people every year. Millions of link plans are done every year by, I'm sure, thousands of people. So it really comes down to the Cambium quality and the way we've integrated and implemented the Telegraph technology.
Okay.
I'm going to second that. I think it's been amazing working with Anthony and his team. I think we see a lot of strength from a technology leadership standpoint in Cambium. The channel readiness and the amazing go-to-market plan you guys have. It's just going to be very supportive of big operators, small operators launching Telegraph. We really hope to see millions of cnWave units be in the market in the next couple of years.
I'm sure Anthony feels the same way.
They're stacked up on the production line, ready to go.
Great. Well, Niraj, I think Anthony's actually on next, so we'll say goodbye and a very, very thank you for joining us today. It's been really interesting. Thank you.
Thank you so much, guys. Thanks. Bye.
Right, so Anthony, you're up next, and it says here you're the father of Medusa technology, but you're going to talk about the 60 gigahertz broadband access for business and residential connections. This is obviously a major highlight, and one of the things I think that hopefully will leave people in no doubt that wireless is the new fibre. So no pressure. Over to you.
Thank you, Brian. Okay, third time lucky. Right, so here we are, broadband access. I'm going to focus on business and residential customers. Now, actually, this actually goes back to Medusa. When we started looking at Medusa in 2014, it was all about how do we bring more data to more customers in a cost-effective manner. So that's why we developed Medusa. Then, because customers were demanding more and more throughput and data they wanted. Now, obviously, times keep moving, and what we're seeing now, whilst Medusa was delivered in 2016, we needed another way of providing more data to more customers. How do we fulfill the Moore's law, where they're just going to keep demanding more? So this is why we looked at 60 gigahertz. 60 gigahertz, we've actually been looking at a company at 60 gigahertz since 2010. In Motorola and then in Cambium, we actually looked at, well, what can we do with 60 gigahertz? It's a frequency which is a great way of utilizing wireless. We looked at a few startups in 2010. We looked at WiGig. We then looked at .11 AD, and we never found a solution which actually was good enough for us, that would actually, we felt that would work efficiently, until Telegraph came along and .11 AY, and we decided, well, we're going to go all in on this. Okay, and we believe this is the way that we can deliver more data to your customers. So again, this is the players in our portfolio: the V5000, the 3000, and the 1000. We'll skip that. Okay, so how are you going to deploy these things? So if we look at this, there's a number of ways that you can deploy these things. Wireless to the home. So utilizing a DN, you can actually just do a point to multi-point distribution to the home. Look at it this way: from a POP or from a centralized point, you can actually just do like a micro POP, where you will just up to 30 users within around about 150 meters, 200 meters. You can distribute that 3.6 gig or 7.2 gig with channel bonding. All our hardware platforms, by the way, are ready to take on that channel bonding. So the 5000 and 3000 can do that channel bonding and be able to get you that 7.2 gigabits per second. So we have this wireless to the home. Now, wireless to the home, Niraj highlighted, can be individual residencies, or it can be the multi-tenant unit. And again, a tower block or a block of apartments, you can individually send data to them, or you can send it to a centralized point at the top. Either way, you've got to have a lot of data to be able to distribute between those users. Next one, wireless to the building. This is where you might want to, as I say, for the multi-tenanted unit, you might send it to a centralized point or to an office block. So again, you've got that opportunity. Rooftop to rooftop, side to building, you can choose either way. And again, you can choose between whether or not to use a V5000 or a V3000, a point to point or a point to multi-point mode. Lots of options. Rooftop to rooftop, we see here. Point to point is perfect for this, where you might want to blast using that V5000, 1 kilometer. You can get that sort of data rates. And we have a trial in Ashburton where we're going to 1.2 kilometers, and we're seeing that 3.5, 3.6 gigabits per second. And that's TCP throughput, not PHY throughput. Fiber extension. Fiber is still is our friend. There's no ifs or buts about this. We're not trying to replace fiber completely, because fiber, we need that for POPs. You've got a lot of data to send around, but rather than entrenching, you can actually, from your fiber points, put in a mesh network, put in a V3000, and then distribute using wireless that last half a kilometer, hundreds of meters, even a kilometer. You can then distribute your data around that using cnWave. Backhaul for 5G, sorry. But it's not all just for 5G small cell. It's also for Wi-Fi, for micropops, for CCTV, also for backhauling your current ePMP or PMP networks. You can use this technology, license free. You're able to get that gigabits per second to these to our other technology, and they all link up together, and again under that one single pane of management with CN Maestro. So enterprise deployment, as you see here, is we have a POP here, right, at the end of the road. Now, you have two choices here as an operator. You can come along, you can trench out this, you can close out roads, you can go through car parks, you can trench out this site. Or from there, you can take a wireless link and start distributing it around. This, if you follow if you go from DN to DN, these yellow squares, this can basically form a mesh across the whole site. If one of these gets blocked, or if one of these links goes down, it reroutes automatically. It's constantly looking for better routes. Each one of these devices has a table inside it where it knows the best way to get data back to that POP, and it's dynamically changing this. Along with these DNs, you can then serve client nodes off these. So these DNs, obviously you can take your Ethernet from these, and you've got a 10 gig link there. in Ethernet. So you can get your 3.6, your 7.2 gigabits per second to the radio. You can actually distribute from the DN itself, or you can use client nodes, up to 30 client nodes of one of these DNs to distribute the Ethernet and the data even more efficiently. And from this, you can put things in like Wi-Fi devices. You could put Wi-Fi around the car park. And in fact, this is something that we did in Ashburton. This is our Ashburton trial here. We've just got 11 devices here, and we're actually distributing Ethernet around this car park for all the users within this business park. Now, what you have here, we have a highway, the Devon Highway here, which actually has a huge amount of dark fiber in it. Yet, when we wanted fiber put into our office, it took 6 months to get that fiber from this highway, trenched all the way down this road, through the park and into our building. We put this gigabit wireless network into that park in 2-3 days. It took to be able to flood that. If we had got the dark fiber from the highway on the radio, we could have done that as well within a day. Installed that. So it's rapid deployment very quickly without having to deal with any councils or any permits for digging up the road. Our link here is the interesting one. We have a 1.2 kilometer link. If anyone gets a chance to come and see us in our development center in Ashburton, we basically have a huge amount of field trials in a very remote farm up the top of a hill there. It's 1.2 kilometers away from our office, but we're now able to get over that 1.8 gigabits per second in that direction, one direction, but it's bi-directional. You actually get 3.6 gigabits per second TCP throughput in that link. Next, deploying in the suburbs. How to do this. At the moment we've got here, we're showing rooftop to rooftop. We formed a very simple mesh of 4 between those buildings there. And then from that, you're able to distribute to the houses around you, right? You could easily just, instead of doing rooftop to rooftop, put it on street furniture. The choice is really down to the person deploying this. Have they got the rights to use the street furniture, or do they go and negotiate with the houses to be able to put this distribution points up? Totally up to you. Again, rooftop to rooftop suburban deployments. So I just quickly want to actually go through, just looking at the time, I want to go through a design challenge that we had. The difference between deploying a radio system like this compared to fiber. So we took this example here where this group of houses, the challenge is to give 100% coverage of this, to give over 100 megabits to 250 megabits per user. And how much would that cost? If you were doing fiber, you would have to trench in and actually pass every single one of these houses through the pavement and road. Obviously, with wireless, you can put an infrastructure in and then just drop in a CN to the houses as and when you need to do that. So what we did is, using the AMP tools and the advanced network planning tools from Facebook, you are able to just drop in all the CNs that you want to look at. You can then just put in all where the street furniture is, or where houses might be. You basically just decide, just flood the area. It then does every combination of links and nodes and works out, can you actually fulfill the requirements, the data rate and the distribution requirements. From that, it's you can see how much simplified it is. You go from having all these red tiers are where distribution nodes could go, right? But after the planner is done, these blue tiers are basically where the DNs are going to be positioned to give you your best capability of being able to see to cover all these houses. So by doing this, we are able to deploy. If you compare the costs, we have spreadsheets to show this if anyone's that interested, but it's around about 55% cheaper doing this than actually putting fiber in. And the reason for this is because you aren't having to pass every single house with with the fiber. You only have to go to the houses as and when you need to. So the cost of deploying the initial deployment is lower, and you only have to actually add the cost when you go and connect the houses up. Because of the meshing system, you don't even have to do all this in one go. You might only just do a few of these DNs if you have to only cover a couple of the houses until you actually can get those orders in. So it's a hugely flexible solution and very quick to deploy. So Cambium, why Cambium? Total cost of ownership, TCO, is low. This single unit, very neat, very compact, low power, relatively low power as well compared to other equipment in this range. Covers that 280 degrees, no site router needed, simple to install. The V1000 and 3000 can deal with different range challenges, can deal with different data rates requirements. The auto beamforming makes it very easy to install as well. Super long range on that V3000 with beamforming. That helps with point-to-point links, with extensions, so you can get to buildings far away without having to put distribution nodes in place, additional distribution nodes in place. So you've got a lot of flexibility there. Channel bonding, hardware ready. So we are able to go from using just that one channel to using a second channel and doubling that throughput as and when you need it. These are all IP66, 67, including the low-cost V1000. High-density deployments. You can get 30 CNs all attached to one DN. But using that 802.11ay standard, teragraph standard, we're able to synchronize everything together. You know what it was like before EPMP came along, before Canopy came along, and we started synchronizing using TDD. Now we have this in 60 gigahertz, and that's a key difference between 802.11ad and 802.11ay. That synchronization, so you can do that high density deployments, right? Just remember what it was like with .11n until EPMP came along. CN Maestro, cloud management. One panel covers all our products. You put this cnWave distribution in, you can then also control your CN pilots, your CN matrix, your CN visions. You know, you can control all these under this one cloud management system. And then easy planning. Most of you will know what Link Planner is like. You can do PMP, PTP plans with this. So very easy, very efficient. All right, I'm just checking my time. And I think I'm right on time. Brian, over to you. Any questions?
Yes, we've got a couple for you. First one, person kindly says, Cambium work magic with Medusa beamforming technology. How will cnWave beamforming make it easier for installers to get it right with such a narrow beam? And will they need special training?
Right. Okay. So two different answers to this: the V5000 to 1000 and the V3000. The V5000 and the V1000. The beam is actually 12 degrees in width, but you don't need to aim this, right? It does it itself. The standard has a technology called IBF, initial beamforming, where the unit basically they start sniffing each other out. They synchronize, they lock, and then they pass a message protocol to each other. After that initial beamforming, there's periodic beamforming going on constantly in the background. where you're looking at micro routes, you're looking at reflections, you're looking at changes in the environment, and then you're slightly adjusting the beamform to get an accurate, to get the best out of the product. As an installer, this is all line of sight technology, right? So as an installer, you just basically put it up, point it, and it will then form those beams and choose the best beam for that. Now, don't get me wrong, you know, Cambium knows a lot about beamforming, and we've had a great start with Telegraph, but we're going to do more than just the standard. Then the V3000, sorry, the V3000. Well, that then is a different beast. That there, you've only got a 0.8 degree beam width, right? Because everything, because it's a 61 dBm EIRP radio, lots of gain, lots of power available. You still do have beamforming on that of 2 degrees. So in order to do that, we've got finder scope mounting brackets to help. But also we will have the tools available in order for you to align and get the best RSSI out of those units.
Okay, and one more question. This is obviously not weather for Britain by the sounds of it. In low rain, dry conditions, what approximate link lengths could we expect?
Actually, and swear this wasn't actually planned, but I did actually expect a question like this. So I've got a quick slide. So if I've got time, very roughly, right? So the V5000 and the V1000, you would expect to get the maximum throughput at 3.7 or 7.4 gigabits per second, around about 100 meters. It's between 70 and 100 meters, depending on the actual conditions as well, and what channel you use, because obviously channel 4 is going to be better than channel 1. The V1000, because it's a gigabit radio, the maximum MCS on that is 10, but it can still do 1.8 gigabits per second at around about 150 meters. You will get 1 gigabit rates out of that radio to around about 250 meters, 200 meters. Oops. Okay. The V3000 can go up to about 450 meters, but channel 4 you get nearly 700 meters. Now, the furthest range you can get is obviously down the lowest modulation mode, the BPSKs, and that's where you can get yourself right up to 1.2 kilometers. You can get that, and that's all because you're using a V5000. If you're doing point to point, we can show you this data. If you're doing point to point with a V3000, as you can see there, a 1.2 kilometer is well within getting the maximum throughput, but you can actually get over, using channel 4, over 6 kilometers with this in the dry. Great. Okay.
I knew you'd have the answer.
Lots of people want to know this. It's important. And Link Plan has all that data.
Okay. Okay, well, thank you for the presentation and thank you for all your contributions today. We're now going to let you have a rest and we're going to go for our next presentation.
Right. Thank you, Brian. Thanks, everyone. Bye.